Good morning, students. Today we'll start our lessons with a problem. The question is, this is a CBSE question, so I thought I'll discuss this with you and then we'll proceed to the theory again. The two charges minus q and plus q are located at points A, which is given by the coordinates 0, 0, minus A, and B, which is given by the coordinates 0, 0, plus A respectively. This is A, okay. How much work is done in moving a test charge from point P, which is given by the coordinates 7, 0, 0, to Q, which is given by the coordinates minus 3, 0, 0. The figure of the same is given on is drawn here, as you can see here. This is minus Q, this is plus Q. Minus Q is at 0, 0, minus A, and the other one is at B, which is at 0, 0, A. So this is the place where I have kept it along the z-axis. I have kept here is the x-axis, here is the y-axis. Now what they have asked is how much work is done in moving a test charge from point P. This is point P to, we are moving it to Q. So this a charge Q is moved, or a test charge, say Q naught. Let us say Q naught is moved. A test charge Q naught is the test charge, okay, or let us say Q naught, let us say that Q naught is a test charge, okay. So that test charge is moved from P to Q. What is the work done? So we know by definition that W is equal to W by Q is equal to V. This is something which I told you in my last class, and I hope you remember it. Potential is equal to work done by charge. Here charge is the test charge that we are moving, so W by Q naught. So therefore what will be the work done? Work done will be potential difference between these 2 points, that is V into Q naught, okay. So this expression that we will use. Now let us calculate it here. W is equal to the potential difference. I'll write it as V into Q naught. So what is the potential difference? Potential difference is actually along this x-axis. Have you noticed that? What is the expression for potential yesterday that I gave you for any charge Q? V is equal to 1 by 4 pi epsilon naught Q, okay, that is definitely capital Q. I will write it as Q here, by R. And this is for one charge, and we know what is the potential due to a dipole. These are the two formulas that I have taught you. One is that is given as 1 by 4 pi epsilon naught P by R square. I hope you remember it. I think that is in another page, okay. So this is the expression for it, P and P cos theta, actually P cos theta by R square. 1 by 4 pi epsilon naught into P cos theta by R square is the potential due to a dipole. So this is actually a dipole. Here you can see it is a dipole because it is minus Q plus Q. Alright, so this dipole and where we are actually calculating the potential difference, we are calculating it on an axis which is perpendicular to it. Have you noticed it? This is in the z-axis. Excuse me. The dipole is in the z-axis, and we are calculating the work done along its perpendicular axis. So what is the angle? The angle will be 90 degree. Have you noticed that? So what will be V here? This V will turn out to be 1 by 4 pi epsilon naught P cos 90 by R square. You know what is cos 90? Cos 90 is 0. So that will turn out to be 0. So what will be the work done? Work done will be 0, because the potential difference is 0 into the test charge. That gives you the work done. Since V is 0, or potential difference is 0, for a total work done will be 0 in this case. I hope you have understood this problem. Let us move to the next topic in our next video. Thank you.